the gap is somewhere between 6 and 8 millimeters. Now that's important because there's a formula that you can use to make this dish correction using this gap. And that formula is you take that gap measurement, divide that number by 8, and that gives you the number of turns on this side spokes that you need to turn every spoke. So in this case, 6 millimeters divided by 8 is about 3/4. So every single spoke on the drive side of this wheel needs to be tightened up 3/4 of a turn. Now remember, if the spoke tension is already really tight on this side, you can do the same thing, but loosen spokes on the non-drive side 3/4 of a turn each to bring that dish error back into center. Okay, since we know that the gap is about 6 millimeters, we use that formula and we're going to turn every spoke, we're going to tighten every spoke on the drive side 3/4 of a turn. Now, in this particular wheel, these spokes are already pretty tight. So I think what I'm going to do, I'm going to go to the non-drive side and I'm going to loosen every spoke about 3/4 of a turn. So, like I said, you're going to do every single spoke. We're going to start at the spoke hole, okay, and work our way around from there. So, I'm going to go to the first one, half a turn, another 1/4 of a turn. That's 3/4 of a turn. Half a turn, 1/4 turn. Next one, half a turn, 1/4 turn. Half, another 1/4. And the last spoke, half, 1/4. Okay, after we have made the spoke adjustment, we're going to recheck the dish with the wheel alignment gauge. If you tighten any spokes, make sure you de-stress the wheel before you put it back on the bike, and check for any lateral or radial truing errors that happen to be on the wheel after you've done this.
Let's talk about how would you go ahead and correct this? We have to pull this rim one way or the t'other.
Right. So the thing to keep in mind is that when you're correcting dish, you're moving the rim, not the hub. So when you know, if we were to look at, let's set the tool for this side. This was the side that we were off. So
if we were to start here as our 0 point,
we would
and
move
come
to
over
this
here.
side. So you see the gap is at the hub. The thing to remember is that you're not trying to move the hub up, you're trying to move the rim over. So we would move it over to the disc side, and you would do that by tightening the disc side spokes.
So we always tighten the spokes to move the rim?
Yes.
Well, what if the wheel's already really tight?
Then you would probably loosen the tight side, maybe a little bit, and then move it over a little bit with the tension.
Two birds for this rock? 2 rocks for this
Two
bird?
rocks for this bird.
We want to move over if we can loosen one side or we can tighten the other. And do we know which is which? Do we have a tool? We do.
We do.
The TM1 will help you know if you're trying to gain tension, if the wheel's low overall tension,
Yep.
you might as well correct the centering.
Yep.
So we're saying this wheel here, it needs to be pulled to the disc side a bit.
Yep.
All right, if it's already at perfect tension and it's off dish, you may end up doing a little bit of each to try and maintain your tension.
Yep.
We're going to talk about that tension here, and when we say balanced tension, we mean per side. And on this wheel here, which is our, it's an acute triangle, we will not have even dish left and right. So let's talk about why. We're trying to draw the rim off the flange center. Let's go through the flange. So our viewing audience might recall that we have a wheel tension app that can do this, but my wheel tension app today is called Ben.
That's gonna be me.
Yeah. So what I want to do, I'm going to take some left side tensions and then some right side tensions, and then see how the two compare here. So I'm going to put our tension meter. We have an 8. I'm seeing another 8. I'm going to go around, and we've looked at our spoke dimension there. So very silent. Oh, 7. Back to an 8. Pretty nicely tension balanced.
Yep.
On this side, readings of 8. So what kind of force are we seeing on that side?
So that's 53 kilograms of force.
Yeah, pulling
on that side.
force 53. Now let's go ahead and try the flatter side here. Yes, oh my, we have 16. We've got a 16, 17. Just skip around here. 17, kind of between 16 and what are we looking at on the right side?
So that's up around 105 kilograms of force.
Right, 105. So definitely tighter here. We could even that out. Okay, get me a spoke wrench. I'll get this tension and this tension the same here. I'll put it in my bike.
It'll be way off.
I'll be
You won't
greatly
able to, You might
disappointed.
not be able to put it in your bike. Actually.
The wheel is going to rub on one side. So this one does not have same left and right side.
Yep.
The drive side tension is good to each other. The left side tension is good to each other.
So the lesson is be good to each other.
That is our lesson for
right,
today.
all right.
So, but what's it going to cause? I mean, it's just going to cause me to crash, man.
It shouldn't. Hopefully not. I mean, the idea is that with these tensions balanced, everything the wheel will stay straight, and it will be actually able to resist those torsional
Right.
forces and everything.
Right. So we're getting plenty of wheel strength in our rim. We're tight. Where you can get good lateral strength is that one-speed hub or our downhill hub. The type of tensions or stresses we see in a wheel we should talk about. There's a twisting stress as you ride the bike. On a disc brake, we have a braking stress. It's going to be the opposite of our torsion, our twisting here. Radial impact, smacking around. But having less dish is good for that radial slamming. All right, so you'd have to design a wheel for crashing and give up a lot of good features.
Yeah.
So when we set tension, when they say, oh, set your wheel tension to such and such value, which side is that?
Generally, it's the drive side.
The tight side.
Yep.
It's going to be the tighter side.
side.
If we were to set 105 kgf tension
Right.
on our non-drive here, we have blown out
Yeah.
the tight side. So whatever, when they give you a tension, it's the tighter side. And on a front disc wheel, it's the left.
the left, yeah.
It's the rotor side, the rotor side. So,
What is the best method to attack radial truing?
That's a good question.
both hands.
Yeah. Calmly. Make sure you've had a very low stress day. With radial truing, you need to, what you do, let's say this wheel received an impact, you went over a pothole or something.
Let me trade you, because this one's carbon.
Yeah, true. Good point. You can't do much there. So if the bend occurs over, let's say it's 2 spokes, that's pretty basic. You would want to tighten each equally to either, if it's out radially, you need to bring the rim in, you tighten each spoke equally, but you want to do it on opposing sides so that you're not affecting the lateral true. If it's over, let's say 3, or an odd number of spokes, you would tighten, let's say, a half turn on one and a quarter turn on these 2, so
Right.
you don't affect your your lateral true.
Yeah.
So that's
So,
one way of.
right. What we're doing on the radial again is trying to affect the up and down of the rim. And that brings another interesting point, the mechanical advantage.
Yep.
All right, especially, let's grab that zip again. Going back to the zip.
We like our zip wheels.
I do. So here, let's talk about the left and right side in terms of bracing angles. Where we put the flanger, where we design it, is going to affect the mechanical advantage. All right, so if I'm the rim up here, I'm going to hold the rim. So Ben's out there. Take your spoke way out there. Look at that mechanical advantage. When he pulls some amount of force, it's going to have good advantage. Come all the way up, all the way out. Imagine a flange well, that's a weird flange, but when
weird
he's
flange.
pulling, it really moves the rim his direction.
Yep.
But as he comes closer and closer to the flange, notice the force of pulling, it's also going, well, toward the hub, but very little bit of it is moving laterally
Yeah.
to the gear side.
Yep.
Well, but come look at my side here. The spoke does stick out. So if I tighten a half a turn on everything on this wheel, I tighten a half a turn, I absolutely am going to have the wheel creep to my side.
So you would want to tighten the shallower angle potentially more.
Exactly.
Obviously, tensions need to be considered, but
Now,
you
yep.
affect more change on the
Yep.
less shallow angle.
Now, if you want to get all mathy and geeky, you can look at the offset and look at the ratios and go figure it out. 2 to 1's good enough. All right? So I'm going to tighten the drive side a half. No, and then this side will be a quarter.
Right.
A half and a quarter and a half and a quarter and a half and a quarter. It's going to creep the tension up, and it may move a little bit, but not a
as
lot.
much, yeah.
Not a lot. So you do get more mechanical advantage, more bang, as they say, for the buck on the non-dish side. So that's a little bit on tension. So hopefully we did some good there for the radial got off a little bit.
Is there ever a situation where you need to loosen a spoke?
Oh yeah.
Absolutely, yeah. Tension balancing.
Yeah.
Any sort of truing operation. Yeah, I mean,
Right.
there are times definitely where you want to loosen a spoke. Again, the main things to consider is the overall tension balance of the wheel, and your TM1 will tell all
Right.
tales.
What
there.
we're talking about tension balance here is the concept that spokes share a zone of influence. So this single spoke, it's not controlling this little piece of rim, it's controlling this zone and it's sharing it with its neighbors. So you'll find a wheel sometimes that there's a really tight spoke and a relatively loose spoke on the same side. This one's doing more of the work. So this is kind of the socialist method of wheel truing. We're going to share the load. We're going to loosen the tension. It would pull the wheel out of true, but we're going to transfer the tension here. Wheels you can almost think of, this is not quite perfect, but it's pretty much a closed system.
Yep.
All right, spokes create tension and energy in the wheel. It's a static tension until we start riding.
Start riding, yeah.
But tightening something is going to pull tension not just on this spoke, it's also going to tighten up these spokes. So certainly there is time, absolutely, to loosen a spoke. So, yeah.
What is there an easy way to identify the tension of a spoke that you can't identify and the manufacturer is unknown?
Very sure. If it's a steel spoke, we know the diameter, the modulus of elasticity, its strain to stress ratio, its stretchiness ratio is the same. Okay, so it's a DT spoke, a Wheelsmith spoke, a blah blah blah, made of steel spoke. If we know the diameter, we know how the tension meter is going to react to it.
Right.
So yeah, but. The brand, the Toise-Étoile, the Union, the Wheelsmith, all the different brands. Doesn't matter if we know the diameter and the material.
Yep.
Yeah.
Yep.
Well, we're stumped. We are
We're
stumped
out
by
of
the
questions,
one.
yeah.
We're stumped by one. So hope that did some good on dish. Check your wheels out.
Oh, one last minute one.
Oh, one last minute question.
What proper spoke preparation would you use? They're saying linseed oil, Loctite, Wheelsmith. What would be the advantage to any of them?
That's a good one.
I've done both. I've used linseed oil. That seems to work pretty well. The spoke prep from Wheelsmith works. Loctite I'd stay away from. I think it's a little too strong, but generally, linseed oil works for me.
Well,
I always
boiled.
love
Make
it.
sure it's the boiled linseed.
Yeah.
Nice on wood and stinky. So you're going to be able to identify your wheel.
What your wheel
So
is,
what
yeah.
they're saying on the linseed oil, you ever taken a cap off your woodworking shelf and the linseed oil, this cap is really stuck.
Right.
That's the effect. They're trying to get the effect of a Loctite.
Yeah, thread locking.
And the Will Smith spoke prep is a liquid you will dip in. It will create basically some material to fill gaps and to create some stickiness in there. So there's different ways. The number one thing they need to have is good tension. All right, things that are tight want to stay tight. Things that are loose are going to come loose. There's actually many times, if you're not using anything, use oil.
Yep.
Some CL1, use some oil
Yep.
because it lets you get tension in the spoke. It helps pull up. Don't be confused. We're getting a little off track. The resistance at the spoke wrench is correlated to tension. But imagine this nipple here is dry, really dry, and lots of friction. Ben's going to turn it. I'm a magical hand grabbing his hand and not letting him turn it.
Yep.
All right, we want that to be lubricated to pull up and give tension to the spoke. That's what keeps wheels tight, is good tension from the get-go.
Yep.